Hi, I'm going to be walking through question 6 of round 2 of the Math Teams Olympiad. This question was a fairly straightforward geometry problem. It was the proof style question, so it needed some sort of logical steps and some reasoning to come to the final answer. And I'm going to walk through a solution now. So we've given this setup as you can see here, and we're asking to see if kxy, well, we're not asking to see, we're asking to prove that kxy is an equilateral triangle. So let's just join kxy in as so. I'm going to do it in red so it stands out. It's a bit off, but we'll just have to deal with it. There we go. So we've got the triangle as so, and the properties of an equilateral triangle is all sides are the same. So we can say this and this and this are the same side, and we can write this down. Lm equals Lx equals Mx. And using that same logic, we can do it for this smaller equilateral triangle here. We see here that considering the triangle SKY, well, the side SY is this length here, and the side SK is this length here. And let's just do some angle tracing real quick. We know this is, we know this is 60, and we can just call this angle theta. Opposite angles are the same, so we can say this is theta, this is 60 like the other one, and this is 180 minus theta. Both of these here are 60. So we've got this set up here, and yeah, considering triangle SKY, we can see this triangle is congruent. So this triangle is the exact same as triangle one second, let me just put this here. This is the exact same triangle as KLX. And this is because of the SAS, side angle side congruence theorem. Congruence theorem, because SY is equivalent to KL, because this is an equilateral triangle. So we can say KL is equal to SM, because opposite sides of the parallelogram are equal length, and because SMY is an equilateral triangle, then this is equivalent to SY. So now we've got this relation that KL equals to SY. And the angle between them is 60 plus theta. Both of them have an angle 60 plus theta. So we can say angle KLX is equivalent to angle YSK, and they're both equal to 60 plus theta. And the third side, which is LX and KS, are both equal to. We can say this because here's one side, here's one angle, and the third side is so because LM, which is this side here, go back, sorry. LM, because it's an equilateral triangle, is equal to this side here, and because it's a parallelogram, it's also equal to this side. So therefore, LM equals LX equals KS, and therefore we've proven these two triangles here have are congruent. Therefore, KY equals KX. So we know this side here is equal to this side. Using that same logic and the same theorem, you can consider the triangle MXY. So MXY, and it's this little triangle down here. And we can also see this side length here is the same, and this side length here is the same. And considering angles around a point, this comes out to be 60 plus theta as well. At least I think it does. Equal 360 minus 60 minus 60 minus 180. Minus 180 minus theta. Therefore, this is 60 plus theta. Nice. So we can then use the exact same logic. I'm not going to write it formally, and we can say all these three triangles here are congruent. So triangle MXY are congruent. Therefore, if they're congruent and these lengths are equal, therefore KY equals KX equals XY. Therefore, we've proved triangle KXY is equilateral.